Did you realize that Onyx parts have a heat deflection temperature of about 300 degrees Fahrenheit? That means that this material, which is a nylon with carbon fiber chopped inside of it, can handle a boiling water and be still very structurally sound. This Onyx material, even though it's printed on a tiny little printer being melted out of a tiny little nozzle, is extraordinarily heat resistant. So much so that as a test, I put some parts on the top of this stove and I got it as hot as I could throughout the day. Now it's a fairly cold day, but I was unable to fully melt these. On one other occasion I was able to melt them, but it took up to about 400 degrees Fahrenheit before I fully started to get them to melt, and they had to be in full contact of that oven. Otherwise, they would not melt. So of course the next thought was, well, let's see how much hotter I can get it. The inside of my stove is about 1,000 degrees in the coals. So I wonder how successful I would be building fireplace tools out of Onyx. So I'm going to try two designs. We're going to torture test them, and we're going to see how well they survive. For the poker, I have a relatively simple design. I want to put a couple hooks on this thing as well as a poker on the end. And in order to give it strength, especially strength when it's extremely hot and the plastic starts to give a little bit, I'm going to add fiberglass reinforcement, specifically high-strength, high-temp fiberglass, which gives me great strength and performance at extremely high temperatures. Looking at the interior of this part as it's going to be printed, you can see that the fiber is going to extend all the way out mostly to the points of these hooks. So my guess is that the tips are going to deform slightly, but whenever it hits that fiber is going to be like armor plating, and it's going to give me strength and rigidity even in the hottest temperatures of that part, as long as I don't let it melt all the way through. Now, because this needs to be laid down flat for reinforcement, the threads are going to come in from the side. So I'll just cut a rectangle the size of a hex nut, and I'll drop it in there so that I can thread this 3/8/16 handle on it and give it a test. Now for the ash scraper, it's a little bit different because I want to put the reinforcement perpendicular to the shaft of that handle, meaning the threads need to go straight up. Anything from a 1/4 20 thread on up, and this is a 3/8/16, you should be able to print threads that are structural in the plastic part as long as it's vertically oriented on the bed. So that works out well. I can print the threads and reinforce this plate with that high-strength, high-temp fiberglass and get a really durable part. Now, I don't actually expect these things to last very long, but I was actually really pleasantly surprised. And this thing never really deformed past that reinforcement layer of high-strength fiberglass. In fact, the only thing that created any meaningful damage to this hook is when I needed to wrench up or lever up the grate, and it made solid direct contact with metal. It was probably around 800 degrees, and as I pulled and tried to kind of push that thing forward, it did melt all the way through to the point where the fiberglass was. But if you look on the backside, it's still structurally sound, the shape is still intact, and the part is still functional, completely functional, other than that damage, that notch that's done there at the top in the polymer section. The scraper did the same thing. I actually used it quite a bit less, but it was more than capable of handling that 1,000-degree intermittent contact with that temperature, and the fiberglass maintains the structural shape of the part as you work. Now, I don't recommend that you go through and build your parts like this for a 500-degree oven. This is not going to work for sustained temperatures. But if it's going to be nearby or around high temperatures and maybe intermittently make contact with high temperature parts, but it's not going to consistently get hot, take a look at Onyx. You're still going to be able to get great performance at high temperatures, and anything that's safe for a human to be nearby, you should be able to have Onyx nearby as well. By the way, if you need something that can withstand the temperature of hot, glowing lava, we do have Inconel parts on the Metal Axe. Just saying.